All right, these are the 5-6 notes. You need to have your textbooks open to page 315. Today is the 16th of January. And we're going to start talking about graphing inequalities with two variables. So far, we've only been dealing with inequalities that have one variable, and we just graph them on the number line. And the same thing was true when we were graphing equations with one variable. You just graphed a dot on the number line where the solution fell. Now, when we start talking about two variables, it's the same as talking about two variables in equation where you're going to have an x and a y, and then when you graph them, you're going to have an x-axis and a y-axis, and you're going to see you're still going to get a line, but then part of your graph is going to be shaded because it talks about that line and everything either bigger than it or smaller than it. So the graph of a linear inequality is a set of points that represents all the possible solutions of an inequality. So that includes its line and then everything that is shaded as well. So an equation defines the boundary, and then the inequality decides which side it's shaded on. So when we're talking about graphs, we also call them coordinate planes. And the reason we call them coordinate planes is because it's a plane, which is kind of like a sheet of paper. It's two-dimensional. It keeps going forever in all the directions. But we call it a coordinate because when you're talking about your location on that coordinate plane, you give it a coordinate. So when we start talking about things like inequalities, by the way, you're going to need a ruler. So if you don't have one, pause the video and go get one. You're going to have a line. That takes your whole plane and cuts it in half. Now, this doesn't look like exactly half. This side is bigger than this side. But if we were to keep extending this out with like those arrows mean, you would see that it just can keep getting bigger and bigger, and it goes on for infinity. And so this line cuts it in half. And that's known as a boundary. I guess I have a box here. Okay. Now, you're going to need something to shade these. I'm going to use highlighters. You can use crayons or colored pencils or something like that. Okay, so you see how it splits it into two pieces. One's pink and one is blue. Both of them are half planes. Now, when we start graphing our inequalities, you'll see good examples of this on the next page, but only one side will be graphed. And so let's pretend that this was blank and didn't have the pink on there. That would be our open half plane because it doesn't include any of the solutions, so it's open. Now, the one that's shaded is considered a closed half plane because it includes all the possible solutions. Okay, turn to the next page. There is only a few more steps to graphing inequalities than there is to graphing equations. First thing you do is graph your boundary or the inequality line. When you go to graph that boundary, it's the exact same thing as graphing an equation. I'm going to show you that. We know how to graph things from standard form and point-slope form and slope-intercept form. Today we're only worried about slope-intercept form. And up here I want you to write use slope-intercept form to graph. Okay? The difference is in inequalities, you have greater than or equal to, less than or equal to, and then you also have greater than or less than. Those things represent different kinds of inequalities. When you see the greater than or equal to or less than or equal to, you will use a solid line. So like on this last page, I used a solid line. That would be greater than or equal to or less than or equal to. On inequalities that just have greater than or less than, you use a dashed line because we know that it does not include anything on that line, but everything that's shaded above or below it is included. After you get that line graphed, you will use a test point to determine which half plane should be shaded. I'll show you how to do that. And then you'll just go ahead and shade that side. Okay, so here's our first example. We graph 3x minus y is less than 2. First thing you should notice, it's a less than symbol, so it's going to be a dotted line. Okay? Before we get started, we're going to change this into slope intercept form. Now think back, slope-intercept form is y equals mx plus b. We don't have an equal sign, we have an inequality sign, but we still have to get it so that y is on its own on the right or left-hand side, and then we have mx and b on the other side. So I have 3x minus y is less than 2. I'm trying to get y alone, so I'm going to subtract the 3x. I'm subtracting because it's positive. And I have negative y is less than, I'm writing negative 3x first because mx comes first, plus 2 because it's positive. And then I want to divide by a negative 1 to make the y positive. Now, when I'm dividing, I have to divide each term. So I have to divide the y, the 3x, and the 2. I'm dividing by a negative, and it's an inequality, so don't forget to flip your sign. So I'm left with y is greater than 3x minus 2. That's slope-intercept form, and now we know how to graph it. So over on our coordinate plane, we're going to take, first we have to make our scale. So I'm just going to go with, this is 1, 2, 3, 4. I think that will everything will fit on there. Don't forget your origin. Okay. Okay. All right, so first thing, B is my y-intercept, and it's at 0, negative 2. So I'm down here, I have to make a point. Then using that point, I have to use my slope, which is m, or the number in front of the x, which is 3. So I rise 3, run 1. 3 is the same thing as 3 over 1. So 1, 2, 3, run 1. Then using a ruler, I'm going to draw in my line. Now, before you draw in your line, remember back to the beginning, it has to be dotted because it's just less than. Okay. Now, the last thing I have to do is choose an ordered pair for a test point. Now, what they're meaning is choose a coordinate that's on either side of your boundary, and we'll plug it in and see if it makes the statement true. I'm going to go with the origin as my test point because it's an easy one. 0, 0 is an easy thing to plug in. So my test point is 0, 0. And I'm going to plug that into the original, so I'm going to say 3x minus y is less than 2. Plug 0 in for that. 3 times 0 minus 0 is less than 2. We're wondering, is that true? 0 minus 0 is less than 2. 0 is less than 2. Yes, that's true. So, what that means is 0, 0 is a solution, and I should shade on the side of my boundary that 0, 0 is on. 0, 0 is on the left-hand side of that boundary, so that's what I'm going to shade. Okay, so now we have our boundary, we have a test point, and we have shaded the appropriate side of the half plane. All right, turn to the next page. We're going to do one together, and then I'll have you do that next one by yourself. So we have x minus 1 is greater than y. Y is already alone, it's just on the wrong side of the inequality. The only thing I'm going to do is just flip things around. I'm going to make y on the left. It's close to y, just like up here, and then x minus 1. I'm going to put a 1 in front of x because I want to know that that's my slope. So my ordered pair for my y-intercept is 0, negative 1, because this is my b, so down 1. My slope is 1, which means I rise 1, run 1. Okay, this is greater than, so it's a dotted line. Okay, I'm going to choose my test point. 0, 0 isn't on the line, so I'm going to choose that one again. And I get, I'm going to plug it into either one is fine. So I'm going to say 0 less than, I'm wondering, 1 times 0 minus 1. Is 0 less than negative 1? No, negative 1 is less than 0. This is false. So instead of shading on this side where 0, 0 falls, I know that that's not a solution, so I can't shade this side. I just simply shade the other side. Okay, So if your test point does not make the inequality true, you just shade the other side of the line. All right, I want you to go ahead and try the next one on your own. Actually, there's 3 more. I want you to try all 3 of them on your own. Pause the video and come back when you're ready. Okay, so first thing I'm going to do is graph. I have my y-intercept at 3, which is 0, 3, so I go up 3. My slope is 1/2, which means I rise 1, run 2. I'm going to use my ruler to draw in my line. It's greater than, not greater than or equal to, so it's a dotted line again. I'm going to choose 0, 0 as my test point. 0 greater than 1/2 times 0 plus 3 is what I'm wondering. Is 0 greater than 1/2 plus 3? 0 is not greater than 3, so it's false. So I'm going to shade on the opposite side. So because it's false, I'm going to shade on the opposite side of the line. Turn the page. So I have x plus 5y is less than or equal to 10, but I want to get y by itself. Remember that. So first thing I'm going to do, subtract that x. I get 5y less than or equal to negative 1x plus 10. I want to get y alone, so I divide by a positive 5. Now it's positive, so the sign stays the same. Y is less than or equal to, I'm going to say negative 1/5 x plus 2. So now I have my boundary, I can go ahead and graph it. My intercept is at 2. My slope is negative 1/5, so I fall 1 and run 5. Okay, go ahead and use your ruler to draw on your boundary. It was greater or less than or equal to, so it is a solid line because it includes that equal to part. Okay, I'm going to choose 0, 0 as my test point again. Plug it in. I get 0 plus 5 times 0 less than or equal to 10. I get 0 plus 0 is less than or equal to 10. 0 is less than or equal to 10? Yes, that's true. So that's the side of the line that I shade on. Okay. The next one is x minus y is less than or equal to 3. First thing I have to do is try to get that y alone. So I'm going to subtract the x. I'm subtracting it because it's positive. I'm left with negative y less than or equal to negative 1x plus 3. Divide by a negative 1. Remember, we have to divide each term. I get y, and it was negative, so the sign flips. Greater than or equal to positive 1x minus 3. Now I have my boundary, and I can start graphing. My intercept is at negative 3. My slope is positive 1, which means I rise 1, run 1. Now, it's greater than or equal to, so it's a solid line. I'm going to choose 0, 0 as my test point. Plug it in, so 0 minus 0 is less than or equal to 3. That's what we want to know. Is 0 less than or equal to 3? Yes. So that's the side that I shade on. Okay? Turn to the next page. Now, usually when we're dealing with inequalities with one variable, we just solve it and put it on a number line. But sometimes they're talking about coordinate planes, and so we can still graph them on coordinate planes. And just like in equations, when we graph those, we'll get either horizontal or vertical lines, but there will be some shading involved. So the first example that I have is 3x plus 5 is less than 14. I'm going to start by graphing that, but I'm going to solve for x first. Okay, subtract the 5. 3x is less than 9. Divide by 3. It's positive, so the symbol stays the same. Okay, so I had to put the graph down on the bottom just because I didn't have room on the paper. But go ahead and go down there. And I know if I have x is less than 3, I'm actually just going to write it in a t-chart like we normally do. And kind of think of it as x equals 3. That's what our line's going to look like. And so it doesn't matter what y is, x is always going to be 3. So I'm going to put my points at 3, 1, 3, 2, and 3, 3. Go ahead and graph those ordered pairs. So I'm at 3, 1, 3, 2, and 3, 3. Now, it is just less than, so it's a dotted line. Okay. I'm going to choose a test point. I'm going to stick with 0, 0, and I'm going to plug that in there. I'm going to say, if I have 3 times 0 plus 5, is it less than 14? I have 0 plus 5 less than 14. 5 is less than 14, so this works. Yes, so that's the side that I shade on. And that's part of step 3 as well. All right, finish with that one. Turn to the next page. There's another example just like that one. I want you to go ahead and try it on your own. Pause the video and come back to it when you're ready. I'm going to keep going. So the first thing I need to do, get x alone. So I'm going to add 3 to both sides. Divide by 4 on both sides. X is greater than or equal to 5. So I'm going to make my t-chart in order to graph it. Remember, it doesn't matter what y equals. So I'm going to put 1, 2, and 3 down. It is always 5 there to find our boundary. It's greater than or equal to, so it's going to be a solid line. So at, let's see, 1, 2, 3, 4, 5, 1, 5, 2, and 5, 3, I'm going to draw in a solid line. Okay, go ahead and I'm going to choose my 0, 0 for my test point again. 4 times 0 minus 3, is that greater than or equal to 17? That's what we want to know. 0 minus 3 greater than or equal to 17, we're still looking. Negative 3 greater than or equal to 17, nope. So instead of shading on this side, I have to shade on the other side. Okay? Go ahead and turn the page. Now, when we start getting into word problems, a lot of times our answers will be limited to only positive numbers because, like for the example, we're going to start talking about selling yearbooks and class rings in the one we're doing today. You can't sell a negative number of rings or sell a negative number of yearbooks. So that's going to draw a different boundary when we go to graph it, and I'll show you what I mean. Turn the page really quick. When we graph it, it's on the next page. Do you see how I stopped with the x and y axis with only a little bit on the other side? Because we don't really care what's happening in the negative number of yearbooks and the negative number of class rings because you're not going to sell negative numbers. So you're going to have a line in here that's going to give you a boundary, but you're also going to have lines here and here at 0 that are also going to give you boundaries because, and notice that these are solid lines, the axes are solid lines because you can sell 0 yearbooks or 0 class rings, but you can't sell a negative number. So when we shade this, I'll show you, but you won't go past the y-axis or the x-axis. And that will be true when you do your word problems on your homework too, that they'll be bounded by the x and y-axis as well as the boundary that you draw in. So let's try our example. A yearbook company promises to give the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35, and each class ring costs $140. How many yearbooks and class rings must the junior class buy to get their picnic? Now, we can all agree that you could sell a ton of class rings and no yearbooks and still get there. Or you could sell a ton of yearbooks and no class rings to get there. So that's where that inequality part comes in, is because there's a lot of solutions that can make this true. You could sell a ton of rings and no yearbooks, or the other way around, or somewhere in between. And that's where that shading comes in, because it's going to show you all the possible solutions that will give you more than or equal to 28,000. The reason we're saying more than or equal to 28,000 is because it says at least, which includes that 28,000 mark. First thing we have to do is set up our inequality. So I know that I'm going to have them buy class rings. And I'm going to let's see, what did I have on the x-axis? I'm going to start with the yearbooks actually. The reason we're starting with yearbooks, and you can set it up either way, but I already had written up the graph for you. Yearbooks is on the x-axis, so I'm going to let yearbooks be x. So I'm going to define that first. Number of yearbooks equals x. The number of rings is then going to be on the y-axis. So when I'm talking about my inequality, I'm going to say for $35 a yearbook, so 35x, plus that $140 for each ring, I'm going to get, when I add them together, the total amount spent on those things. And we want it to be bigger than or equal to the $28,000 that the company wants us to buy from. So now I have my inequality. But I have to graph it to see what my possible solutions will be. So I'm going to have you go over to the next page and we'll start doing that. So we have 35x plus 140y is greater than or equal to $28,000. We know that in order to start graphing this, I have to get it in slope-intercept form, which means get y alone. So I'm going to subtract the 35x. So I have 140y is greater than or equal to negative 35x plus 28,000. Again, I put that negative 35 out front because mx plus b is slope-intercept form and I want it to come first. So the last thing I have to do to get y alone is divide each term by 140. Okay, so now I have y is greater than or equal to, it stays greater than or equal to because it's a positive number you're dividing by, negative 35 over 140, which can actually be reduced. So let's start reducing it. We have negative 35 over 140. I'm going to divide by 5. I get negative 7 over 28. Both of these are divisible by 7. And I get negative 1/4. So that's a much friendlier slope to deal with than negative 35 over 140. So let's go over here and we're going to write it as negative 1/4 plus 28,000 divided by 140 can also be reduced. I'm going to just cross off those end zeros. And then I have 2,814. That can also be reduced. Both of these can be reduced by 14. And that just becomes 200. 14 goes into 28 twice, and then we have the 2 zeros. So now I have an intercept and a slope that I can deal with, okay? In most of your word problems, it's going to work out that you can reduce them to friendly numbers that are not 28,000 on a graph. So let's go ahead and get started. My intercept is at positive 200, and my slope is at negative 1/4. Something to keep in mind is that I go up by 20s on this side and over by 80s on this side. So we'll have to be kind of careful how we are moving. You can't just come down 1 and over 4 because that's actually coming down 20 but over 320, which doesn't work for us. So if I go down 20 and I want to go over, I'm trying to do 1/4. So in order to get to down 20, how much do I have to go over on the other side? So to get from 1 to 20, I just multiply by 20. So I have to multiply by 20 on the denominator as well. So 4 times 20 gives me 80. So I'm going to fall 1 and then run over to 80, which is fortunately for us just over 1. Now, it looks like we're just falling 1, running 1, but in scale of things, we're falling 1, running 4. So we can just keep going like that. Okay, it's greater than or equal to, so I have a solid line. Okay, that's my boundary, but like I said before, I'm going to have some boundaries in my x and y axes as well. But before we get that far, let's go ahead and pick a test point. I'm going to choose the origin or 0, 0 as my test point again. And instead of going back to this original problem with all these big numbers, I'm just going to stick with this one. I'm going to say, is 0 greater than or equal to, this should be an x in there, I'm sorry, negative 1/4 times 0 plus 200. So is 0 bigger than or equal to, is 0 bigger than or equal to 0 plus 20? Is 0 bigger than or equal to 20? No. So I'm not going to shade on this side, I'm going to shade on the opposite side. So when I start shading, keep in mind that I can't go past the y-axis. I can shade all of this stuff, and when I get down here, I can't go below the x-axis. So it's all of this stuff up here. If they sell this many class rings in yearbooks, they'll get that picnic. But I'm bounded by these axes because we can't sell negative numbers of things. Okay? So, this is the end of the notes. You should go ahead and take a look at the homework. Don't forget that you need to finish the 5-5 homework. I will see you in class tomorrow and we will talk about some examples.